Okay, in this one I'm going to show you what is the static initialization fiasco in C++, which is a great name for a linking trick which is very sneaky. So here you can see I have an application, a little main, where I have two global variables, foo and bar, which both have some members. And so the trick is that if I compile it like so main foo bar, and then I run it, you can see that foo value has some value and bar derived has some value. But if I changed the order in which the files, the translation units are compiled in, or linked in, you can see that suddenly bar is equal to 0, which is kind of surprising since I haven't changed the code at all. So let me show you how this works. So unlike C, C++ allows a code to run at static initialization. So static initialization is right before your main runs. So if you decompose the executable that results in this compilation, you will see that before this print and so on, there is some instructions that are run before the main runs. And so that happens when you use, for example, the constructor of a global variable. So let me show you. I have a foo.hpp file where I defined a struct foo and a struct bar, and they both have these members, and they both have a default constructor, and the foo class has a get member function. And there is we also declare that there is global variables happening in that are not in this that are in other translation units. And so if we go in foo.cpp, we can see that it's very simple. The constructor just initializes the value to 21, and then the getter just gets the value. And here we define that in this translation unit, there will be the gfoo global variable. And so then if we go in the bar file, it's also very simple, except that the derived uses the get function from the foo class to get the derived value. And this is in the default constructor of bar. So what will happen is that the linker can either, well, let's do a little linker thing here. It can either execute this, then this, where this is value, and in this case, since value is initialized to 21 here, by default, all the static stuff is equal to 0. So it's like there is a value is equal to 0 and derived is equal to 0. And so here, derived would be equal to 0, but what it can also choose to do is that it would first execute the foo constructor, and then the bar constructor, and then we would have this order. And so this is like the stuff that we want, where derived actually uses the value 21, and this is the stuff where there is the static initialization fiasco. So yeah, this was just a little showcase of this. Now maybe let me show you how you can work around that. Well, I mean, maybe generally when there is these kinds of stuff, that means that you have some kind of design issue, which was my case at work, but I choose the workaround anyway because no time. So what you can do is simply use functions to access your global variables. So what I mean is, so you can create these functions, which are simply wrappers around creating around your static variable. So since static variables inside of functions are initialized as soon as you call the function, not at static initialization time before your main, that means that whenever the first call to gfoo is made, it will initialize the struct. So, and this way you don't have this initialization fiasco here. So you see I just have a wrapper function for gfoo, and I have a wrapper function for gbar. They just return references to the struct, and whenever you need to use it, you need to use the parentheses since it's a function, but basically it, I mean, it should be a no-hop, I think, since it's very simple. Well, except on the first call, it should be optimized away. And so you can see in the main as well, like this. Oh, I haven't showed you, but of course, the good case still works. And now the case that before failed now also works. So there you go. That's the proof that it works. Anyway, I hope this will prevent you from falling in this pitfall when you code your C++ application. Yeah, I fell into this at work because I think I was compiling my application with MSVC on Windows, and everything was working fine. I had a lot of static initialization, and it was all running smoothly. And then I switched to Linux, and all of a sudden GCC well had just a different order in which it wanted to compile the files, and I had this very strange behavior where some of my structs weren't initialized. And yeah, that's the first time I stumbled upon this, and it was very strange and kind of cool. So yeah, I hope you enjoyed the video, and I'll see you in the next one.